Welcome to Android Video Lesson Shorts Edition. My name is Sebastian Colbert, and in this lesson we'll learn about activity lifecycle. The nature of mobile apps is that they can switch from running state to paused, then to stopped at any point in time. That is why managing the lifecycle of your activities is crucial to developing a stable and flexible application. The life cycle of an activity is directly affected by the change of state. An activity can exist in three states: resumed, or also called running. The activity is in the foreground of the screen and has user focus. Paused, another activity is in the foreground and has focus, but the original one is still visible. A paused activity is completely alive and retains its state, but can be killed by the system in extremely low memory situations. Stopped, the activity is completely hidden by another activity and is now in the background. A stopped activity is also still alive, but is not attached to the window manager. Since it is no longer visible, it can be killed by the system when memory is needed elsewhere. When an activity moves into and out of different states, it is notified through various callback methods. These callback methods are hooks that you can override to do appropriate work when the state of your activity changes. The following skeleton activity includes each of the fundamental life cycle methods. Don't forget to always call the superclass implementation before doing any work via super. Let's go through the lifecycle callbacks. OnCreate gets called first. This is where you should do all of your normal setup like creating views, binding data to lists, and so on. OnStart is called just before activity becomes visible to the user. It is also a good place to maintain resources for showing activity like registering broadcast receiver. OnResume is called just before activity starts interacting with user. Any work here should be lightweight, as OnResume can be called frequently. The activity is now running. OnPause is typically used to commit unsafe changes to persistent data, stop animations, and other things that may be consuming CPU, and so on. As with OnResume, any work here should be lightweight. At this point, another activity is in foreground. Should the user return to original activity, OnResume would be called. Also, it is possible that in this state, app can be killed if memory is needed. OnStop is called when the activity is no longer visible to the user. This may occur because it is being destroyed or because another activity is covering it. Should the user navigate back to the original activity, OnRestart will be called, which then calls the OnStart. Again, app process can be terminated here to free up memory for other purposes. Finally, OnDestroy is called when the activity is finished or being destroyed by the system. Now that you understand the lifecycle callbacks, let's examine how they interact between two activities. First, activity A is shown, which triggers OnCreate, OnStart, and OnResume calls. This activity is now visible. Assume that a button was pressed, which will show activity B. Activity B calls OnCreate, which triggers activities A OnPause call. Activity B's OnStart and OnResume complete, which forces activity A to stop. Activity B is now visible. Let's say user is done viewing activity B and presses the back button. Activities A OnRestart will be called, followed by OnStart and OnResume. At this time, activity B will pause, stop, and eventually will be destroyed. Finally, activity A is closed. That is all for this lesson. Visit androidvideolessons.com/shorts to get access to source code for this and other lessons. I hope you enjoyed this lesson, and I wish you happy coding.